Is this thing on? The world of chemistry. This year's project week was about biochemistry. When Sara, Isabella, and Moa found this out, they began thinking about what chemistry really was about. Albert Einstein once said that if you look deep enough into nature, you will understand everything better. Was this the true meaning of chemistry? To find this out, they set out on a journey to find the answer to what biochemistry is all about. Moa stayed in school. In school, I did a lab where we isolated muscle proteins from fish. We had 5 different fishes, which we were supposed to compare and, with the help of the results by the lab, link together throughout evolution. We began by taking a small sample of the first fish, grind it, and placed it in a test tube along with a liquid which made the protein slightly negative. This solution was then placed in a water bath at about 90 degrees Celsius for 5 minutes, and then centrifuged for another 5 minutes. This denatured the proteins and made the waste product sink to the bottom, whilst the proteins stayed on top. We then removed this solution and placed it on a thin gel. This was then electrolyzed. The negatively charged proteins were drawn to the positive anode, the light ones traveling the furthest, and the heaviest one traveling the shortest distance. We then stained the gel to see the proteins clearer. Dr. Pratt and Mr. Nicholas had ordered chemicals which were necessary to be able to carry out the lab further and to identify the proteins. But the chemicals did not show up, which made both Dr. Pratt and Mr. Nicholas a bit cranky. Isabella went to find the answers at Stockholm University.
At Stockholm University, we were introduced to chemistry as a subject that is preparing for future work. Our task for the day was to synthesize a pharmaceutical compound. We were equipped with a substance called Substance A, an acetic acid anhydride, which we were to crystallize and analyze using alvedon, iprene, and magnesid, and comparing these with our purified product by chromatography. Simply, our assignment was to figure out what substance A was by evaluating results from the chromatography analysis. We came to the conclusion that we made alvedon, so substance A must have been p-aminophenol. The process we used were, as I said, chromatography and crystallization. Chromatography is a process used to separate mixtures of substances into their components. As the solvent slowly travels up the plate, the different components of the dye mixture travel at different rates, and the mixture is separated into different colored spots. The solvent rises up the chromatography paper by capillarity. Crystallization refers to the formation of solid crystals from a homogeneous solution. It is essentially a solid-liquid separation technique. The result of this investigation was 2.6 grams of alvedon. By using the facts that was given on the handout sheet and what we found out, we were able to calculate the theoretical yield of alvedon. To find the theoretical yield, we need to find the limiting reagent. In this case, the limiting reagent will be the substance that runs out first, since the molar ratio is 1:1. So the p-aminophenol will be the limiting reagent, since it has the least number of moles. Because there is a 1:1 mole ratio between acetic anhydride and aspirin, every 1 mole of acetic anhydride that you use up produces 1 mole of aspirin. The theoretical yield of aspirin is 0.1 moles, or 1.1 grams. In the procedure, we were told to recrystallize our product. We believed that we had to do this in order to make a pure product, since the major impurity in alvedon can be further removed by recrystallization. At Stockholm University, we were given instructions which could easily be followed. We were paired up and began the lab practical. If we had any question, there were 2 instructors that gave us the support needed. So there weren't so many decisions we needed to make, since we got all the information and instruction on a handout. I think that this lab investigation went well, and it were clearly stated what we were supposed to do.
Sara went to see if she could find any answers at AstraZeneca.
AstraZeneca was located in the middle of nowhere.
in huge buildings with very high security. The staff welcomed us very kindly and told us about AstraZeneca. They said that they are huge tablet producers and big money makers. We were also told that they by law had to, before selling any of the medicines to humans, test it first in test tubes, then on animals, and last on humans. We got to see animals, dogs and rabbits. What a testing on animal is being done is to see if any of the medicines have any negative effects on the animals. We were told that animals weren't allowed to live that long, since they have to be put down in order to look at the inside organs. It was weird seeing the animals living in an environment that was sort of like a prison. Most of the animals were never allowed to go outside. Although there are very strict rules that have to be followed to ensure the best for the animals, they are being forced to take medicine that may have bad effects on them. After a visit to the animals, we discussed the ethical issues of testing on animals. Is it wrong or is it right to use animals in order to fulfill our needs?
School, university, and AstraZeneca are all different stages of biochemistry. If you compare the chemistry at Stockholm University to AstraZeneca and the chemistry in our school, there are great differences. The chemistry in our school is for preparing students for further studies. Meanwhile, in Stockholm University, you are preparing for future work at places such as, for example, AstraZeneca. Also, there are some great differences between the material used. For example, in our school, the material isn't as advanced as at AstraZeneca or even at Stockholm University, and we assume that it is because the chemistry is at a lower level in our school than at Stockholm University and AstraZeneca. Also, there are more to lose for AstraZeneca since their investment cost a lot more, so if anything goes wrong, there is a lot of money and material that have been wasted. The labs in school are very basic and not very independent, and they are carried out under the supervision of teachers. The lab practicals are also short, and the materials is simple, so they can be used by everyone and reused at several occasions. At Stockholm University, the lab practicals are more advanced, and the students have more freedom to choose their work, and they have more access to materials and equipment. The labs at AstraZeneca were more high-tech. Since the work carried out there will eventually be used by humans, materials and equipment has to be at the top level all the time.
The work by AstraZeneca is revolutionary for the development of human health. But for the medicine to be 100% safe for the humans, they have to test all the medicine on animals. Even though it is very unfortunate for the animals, they cannot take any risks which might have harm to the humans. This led to fierce discussions in our group about whose life is worth the most and how much we are willing to sacrifice for our health.
Furthermore, AstraZeneca had a very high safety procedure. Since their product would be used by humans, they cannot risk anything going wrong in their production. They also work in an environment close to viruses and bacteria and does not want to risk to become sick themselves. In school and at Stockholm University, the safety procedures are not as high as at AstraZeneca, since the labs are not as advanced and does not involve as big risks. However, in the end, all three institutes are very dependent of each other and each other's work. We get our knowledge base at school, which we then develop further at the university, which we then use in our working life. The lab practicals that we carried out in school was to isolate proteins in fish. To know how to treat the disease, we first have to isolate the proteins to see what's wrong.
The next step is to create a possible solution which can be compared to the work we do at Stockholm University. Then the medicine have to be tested and mass-produced as it is at AstraZeneca. You have to apply your knowledge from school and the university in your future work, but in places as AstraZeneca, you also have to include questions of ethics, environment aspects, etc.
As a group, the three worked very well together. Since Sara was traveling to America, they agreed to make a film so that everyone could participate. They worked very hard and eventually found the answer to the question. Biochemistry is everything and everywhere. No animals were hurt during the production of this movie.